Good evening, everybody. It's John here from Tutor to You, welcoming you along to another of our live streams for Geography A-Level. And tonight, we're talking and thinking about glacial systems and landscapes. I did have a little reminder down right by my notepad here. Big welcome to everybody who's joining us live, and of course a big welcome to anybody who's joining us on catch up on replay. I'm joined tonight by Brendan in the middle of the screen, and I've got Alice on the right hand side. Good evening, both.
Hi.
Good evening, everybody.
Brendan, do you want to give us a few words about what we're covering tonight?
Yes, there's lots and lots of information this evening and lots of knowledge to retrieve. This is an excellent topic, glacial systems and landscapes. One thing that people often think that glacial systems and landscapes applies to some place much further north than where we are. But the whole of the United Kingdom and the British Isles was profoundly affected by glaciation, and you can see the remnants of it in absolutely every part of the country. So anyway, this is a really good topic, and we're going to kick off with a section on confusing pairs with Alice.
Thank you, Brendan. Okay, yes, I'm going to show you a set of, 5 pairs of key terms with their definitions. And what I'd like you to focus on is whether the definitions are correctly matched to the key terms. So if they don't match, you might want to type something like switch in the chat box, or if they match, you could type match or yes, they work in the chat field. So those of you who are joining us live, we'd love to hear from you and get some of your answers. And if you're watching on catch up, of course, you can pause the video and take some time to read perhaps more carefully. All right, so question 1, we're thinking about these matches or not. We're starting off with some nice easy key terms from physical systems. Okay, so remembering across paper 1 we use the concept of a system, thinking inputs, outputs, stores and flows to make sense of the way physical environments function. And here we're focused on, of course, on glacial systems at a range of scales, from a single glacier advancing and retreating across the year, to the cryosphere, by which I mean the store of water as ice across the entire globe and how that fluxes over time. So yeah, I can see we're getting a few answers in the chat as people have a look at these key terms. Are these key terms correctly matched to their definitions? We've got input, we've got output, and the answer is, John, yes, they are. Input is, of course, the energy or matter coming in from outside a system. In the example of glacial systems, we're thinking of solar energy or geothermal heat, snowfalls and rockfalls. An output is energy or matter moving out of the system, such as meltwater, icebergs, or evaporation. And this makes us think about different types of systems. So clearly, a single glacier is linked to an open system, where we have meltwater draining away towards the sea in spring and summertime, whereas the whole of the water cycle we might see at a global scale as a closed system. So just another reminder about some key terms there. Let's have a look at our second set of confusing pairs. So here we've got flows or transfers, sometimes fluxes with a definition, and we've also got stores or components with another definition. Have a look at those. Are those correctly matched, or do we need to switch up the definitions? Do have a go in the chat if you think you know the answer. I'll give you a moment to have a look. And John, if you could reveal the answer. No, we needed to switch them up. So the stores, of course, include permafrost, ice sheets and glaciers in the case of glacial systems. And these are all subject to change, of course, depending on the season or on a longer term basis, depending on average global temperatures. Flows or transfers are the movement or flux of material and energy linking those stores, and they are processes like melting, carving, evaporation, sublimation, but also processes of glacial movement such as internal deformation and basal sliding. What about our third set of confusing pairs? Okay, so when we're thinking about systems, we need to consider whether they're in a state of balance, or more likely we might call it dynamic equilibrium. over different periods of time. So, for example, if a glacier advances in winter as much as it retreats in spring and summer. Now, clearly around the world, for most glaciers, this isn't currently the case. Alternatively, some systems might be moving away from a steady state, and whether there's a particular physical trigger for this. So it leads us to thinking about different types of feedbacks. Can you remember the difference between positive and negative feedback? We've got two definitions here. Which is which? Take a look. Okay, and John, if we could see the answer now. Yes, so these are correctly matched. So a positive feedback is a change in a system that leads it to move away from dynamic equilibrium. And if we think about glacial systems, we might be talking about something like Arctic amplification. This is the idea that with the melting of sea ice, there's and this might be as a result of increased emissions from human activities like burning fossil fuels. That initial change leads on to a second problem or other problems, knock-on effects, in terms of the degree to which the sun's rays reaching the poles are reflected. Now, ice reflects more energy than water or bare rock. So with less ice, so sea ice or ice on land, we in fact will have less reflection, which means more warming and in turn more melting with higher surface temperatures. So if you like, it snowballs. Terrible pun for this. Interestingly, scientists have just produced a report in time for COP27, which is currently meeting in Egypt, to say that the complete loss of Arctic sea ice is in fact likely within a decade. The Arctic is apparently warming at a rate that is 4 times the global average. So it's really worth you knowing some of these key facts about the Arctic ahead of your assessments. A negative feedback loop is completely different. Sorry, John. It's one where a change to the system eventually leads to a mechanism that checks the original change. And if we're thinking about glacial systems, we might look at the fact that with greater land revealed with melting ice, more plants can grow. And perhaps if those plants are sequestering carbon from the atmosphere, this could start to negate the effect of warming as they remove carbon compounds that were in the atmosphere produced that were in fact enhancing the greenhouse effect. In reality, most scientists believe that all that methane escaping from melting tundra landscapes will overwhelm any gains in terms of sequestration rates from growing shrubs and mosses in a warmer world. Sorry, John. Question 4. So we've got another set of confusing pairs, and we're thinking about the different types of landscapes we need to know about when we're thinking about this cold environments topic. So what's the difference between glacial landscapes and periglacial landscapes? Are these key terms and their definitions correctly matched? What do you think? Pop it in the chat for us. And the answer is yes, they are. Glacial landscapes are very different to periglacial because with glacial we're thinking about areas that are covered by ice and snow year round, compared to periglacial, which are experiencing certainly penetrating frosts and snow cover, but they're also experiencing greater fluctuation of temperature and are shaped by weathering and mass movement. And then our last confusing pair, what's the difference between a glacial landscape and a glacial landform? What do you think the difference between a landscape and a landform? Are these definitions correctly matched? And we'll move on quickly because it's a nice easy one. Yeah, they need to be switched around because clearly a landscape is a combination of features, for example, across the Lake District, whereas a landform is just one part of it, such as Great Langdale in the Lake District, which is a U-shaped valley carved by a glacier, but still evident in the UK landscape today. So back to Brendan now, who has a bubble quiz for us.
Many thanks, Alice, and lots of really good extra details there for people. So if you want to watch this again later, you can. The PowerPoint and the video will be available. And it's a very good idea to go through each section one at a time and really get a little bit more from it. And the other thing is that you can do for the next activity and one or two of the other activities, have a pen and paper ready. There's not a lot you need to write down, but it just might help to focus what your thinking is. And also, please do jot the things that you think in, share your thinking in the chat. So in case you haven't seen the bubble quiz before, what happens is there are 4 possible answers presented to you for a question, and any number of them, from none of them up to 4 of them, can be correct. So let's have a look at the first one. The first one is, which of the following terms, if any, because it could be none of them, but it could be 1, 2, 3, or 4 of them, which of the following terms, if any, correctly refer to the geological epoch of the most recent ice age? So jot your ideas down on a bit of paper, and if you feel so inclined, pop them in the chat as well, and we'll see how we're getting on. I can see somebody's got a wrong answer, and we have a right answer, at least 1 or 2 right answers. Good. So the correct answer to this one is the Pleistocene. Now, that is not to be confused, of course, with plasticine. Check your spellings. However, that might be a way of you remembering it, because glaciers tend to have what's called plastic flow. So if that helps you to remember, so be it. Okay, question number 2. Which of the following, if any, are characteristics of the tundra biome? You need to know your biomes. So a lot of the biomes that we consider, some of the biomes are linked with glaciated areas. So the 4 choices are: A, very high net primary productivity; B, high biological diversity of flora and fauna; C, small, slow growing flora; and D, low insolation. Notice it's insolation, not insulation. No darkness in summer. So which of those, if any, are correct? Jot your ideas down. How many of these, if any, are correct? Let's reveal that it is just 2 of them. So the characteristics of the tundra include small, slow-growing flora and low insolation. That's to do with the amount of radiation that you get from the sun, and of course very little light in it, and there's no darkness in the summer. That's a characteristic there, but the sun never gets very high in the sky. It just doesn't particularly get dark. Question 3. Which of the following, if any, are characteristics of the polar biome? So these are characteristics of the polar biome. Could it be any of these? A, frequent high pressure or anticyclones. B, high albedo due to reflectivity of ice and snow. That's a key word you need to know, albedo. Low insolation, negligible daylight in winter. And D, frequent low pressure systems or depressions. So which of those, if any, are correct? Someone's quick off the mark and not quite right, but there is a correct answer. Go for it. The correct answer is 3, ABC. The only one that's incorrect there is frequent low pressure, which I suppose is fairly obvious if you think about it, because you can't have both high pressure and low pressure. You have to make sure you're choosing the correct one, though. So high pressure systems are characteristic of the polar biome. Number 4, please, is which of the following characteristics, if any, are typical of tundra soils? Is it A, blue-grey in colour; glade, that means they have anaerobic iron compounds; B, soil horizons are unclear; C, waterlogged in summer; or D, thin acidic organic layer near the surface? Which of those, if any, are typical of tundra soils? Go for it. Go for it. And the correct answer there is all of them. So, fairly clear cut. These are all characteristics of tundra soils. And the anaerobic iron compounds are quite interesting. We often think of iron compounds appearing in the landscape in a red colour, but in this sort of landscape where they don't have much access or any access sometimes to oxygen, they appear grey or glade. So that's the explanation for that first one. Number 5. Which of the following features, if any, are found in glaciated landscapes? So these are 4 quite simple terms. So which of these, if any, would be found in a glaciated landscape? A. Ribbon lakes, B. tarns, C. fjords, and D. rías. Which, if any of those, are correct? Somebody thinks 2 of them. Somebody thinks 3 of them. What do we think is the right answer there, Jim? 3 of them are correct. And that's ribbon lakes, tarns, and fjords. Rías are not correct there because they wouldn't be found in a glaciated landscape. However, they do occur due to the aftermath of glaciation because they are drowned river valleys, such as Sydney Harbour, but there were never glaciers in Sydney Harbour. Okay, question number 5 is over, and we're on to the connection wall, and it's back to Alice.
Thank you, Brendan. I wasn't aware that Sydney Harbour was a RIA. Learning something every day here. So our next activity, the connection wall, we're going to see a wall of 16 phrases or facts linked to the glacial systems and landscapes. And I want you to think about how you might group them together because we're going to group them into 4 equal groups. So let's have a look at the wall. Okay, and notice with our wall we've got letters along the top and numbers along the side. So if you want to tell me which ones you think fit together in a group, you could, if you're watching on catch up, jot down those grid references on paper before we reveal them, or put them in the chat if you're here live with us. Okay, so thinking about those 4 groups, can we see facts that are linked to different types? That's my clue, different types of cold environment. If I was to tell you the first heading for a group is the idea of polar cold environments, could you give me the right grid squares? Which of those relate to polar environments, a type of cold environment that we need to know about? Okay, let's have a look at the answers then, John. So polar environments clearly include locations in the Arctic Ocean, e.g. the North Pole, and locations inside the Antarctic continent, e.g. the South Pole. We're thinking about icy environments dominated by huge ice sheets and associated ice shelves. And of course, our 4th box there is the idea about extensive sea ice. Okay, so what other types of cold environments beyond polar do we need to know about here? A few ideas coming up in the chat. I'll have to do this in the right order, won't I? So if I tell you the next heading is alpine environments, which of those grid squares relate to alpine environments? Okay, John, do you want to reveal them? So look at those green boxes then. Alpine environments can occur at any latitude, in contrast to polar environments where we're really thinking about high latitude, as long as the altitude is such that ice remains year round, or perhaps used to. So of course we're thinking about high mountains, the Himalayas, the Andes, Rockies, European Alps, and the Southern Alps. These are areas where we see large temperature ranges across the year, or larger temperature ranges across the year than we saw in polar environments, and where glacials and interglacials have shaped the landscape. Okay, so we've had polar, we've had alpine. What other way of classifying or making a distinction between different types of environments do we have? Well, we might be thinking in terms of glacial and periglacial environments. So there I've given you the last 2 group headings. So for glacial environments, and I appreciate that that does describe the two I've already talked about. What else would you put into that? Okay, thank you. John's given us the answers. So we can see that glacial covers both polar and alpine areas. We're talking about areas where large amounts of ice remains year round. Some areas are outside the Arctic, and notably Greenland is included here, which we haven't mentioned, and is the site of a large ice sheet alongside Antarctica. Of course, we're thinking about the impact of the advance and retreat of ice at the edge of ice shelves, those valley glaciers, and the changes that they bring. So by process of elimination, John, we have the final four relating to periglacial environments, which can occur in high latitude areas with low precipitation, where tundra is the dominant plant animal community, and it's shaped by those low temperatures, a low range of temperatures, and of course, permafrost. Locations being North Alaska, North Canada, Northern Scandinavia, Svalbard, Siberia. Okay, so how did you get on with the connection wall? If you weren't sure about it to start with, as Brendan was saying, pause the video, have another look. These are the types of categories of environment we're going to need to be able to identify.
Many thanks, Alice. Brilliant work there. Now, you see a landscape in front of you here, which applies to the next activity. And we're showing you this because this is what a landscape might look like during the glaciation. You can see lots of ice and snow around, perhaps a glacier filling the valley. But it's not going to be like that forever if the glaciation finishes. And we know that the period of glaciation, or the ice age, finished, some thousands of years ago. So when the ice and snow has melted away, we start seeing a different landscape like this one. And you can see in particular, this is a very beautiful landscape in Switzerland with an extremely famous mountain called the Matterhorn. And so the change of analysis that we're looking at here are, how did we get from the glaciated landscape to the post-glacial landscape you can see? And you can just combine those two images in your mind for this activity. So the activity of change of analysis is to rearrange some statements, to kind of think through the process, to think through the story of how the landscape came to be like that. Think of it as a story you're telling. So if we have a look at the items in the chain, we have 5 items. I'm not going to read through all the details for you, but I will give you time to read through them. I'll just mention the heading really for each one. So we have 5 items, but they're not currently in the correct order. So how are we going to rearrange these for the correct order? So if you do have a pen and paper, or you're inclined to put them in the chat, you just literally need to write 5 numbers, but they have to be in the correct order. So the first item is rotational flow. Just have a read through the detail on that. And the second item, corries deepened. Have a read through the details on that. Note as well the processes that are described. That's very important, that you're thinking about the processes. The third item, a pyramidal peak. Have a read through the details on that one. You'll notice there are some associated glacial features there. The fourth item, Nivation hollows. Have a read through the little paragraph on Nivation hollows. You may notice with each of these there are other key terms. So in this case, there's quite an important one there called neve. So if you're not sure what that is, you might want to look that one up later. And number 5, corrie glaciers is the 5th item. Have a read through that. You'll notice plastic flow is mentioned. We hinted about that earlier on. And what you can see in that one as well is a key term which has been borrowed from another language, which is from German, Bergschrund crevasses. And quite a lot of the terminology in glaciation borrows from other countries' languages. The word corrie, in fact, which you've seen here, is essentially a Scottish term. If you go to Wales, they would call them cwms, CWM, or if you go to France, they would call them cerques, like a bit like a circle. So, rearrange the statements. Let's see what you've got. Have you put them in the correct order? Okay, let's reveal the correct order. The correct order is that we start with the Nevation hollows. That's where the snow builds up, and snow layers gradually over the years weigh down on each other, and their mass compacts the lower layers of snow, so it becomes something called neve, which is a kind of halfway stage between snow and fully fledged glacier ice. Then the next step would be corrie glaciers, because the corrie glaciers would start to form from the glacier ice in the previous stage, and they will start to gradually move and slide due to gravity through plastic flow and rotational flow. Okay, the third one that you should have written is rotational flow. So the rotation occurs because the glacier is sliding due to the force of gravity, and then it has slightly different types of flow, such as compressional flow, perhaps in the base of the corrie, and then as it goes up over the corrie lip, which is the edge of this armchair-shaped hollow, it has extended flow or extensional flow, which causes crevasses and seracs to develop, which are kind of sharp, very dagger-like sections of ice. And if any climbers are going up in these areas, they're very, very difficult to negotiate. So any of the climbers going up Everest, for example, will report that. And by the time we get to the end of this stage, an embryo corrie is formed, like a baby corrie. The next step, the corries are deepened, and this is including very strong abrasion, which is assisted by subglacial debris, and that's when the glacier is moving, but it's carrying rocks underneath it, which are literally scraping the underneath bedrock, and they cause striations, and they do a lot of erosion. And they also will grind those bits of rock, and eventually they'll become rock flour. And all that debris is transported with the ice. Some of it gets left behind, but some of it will contribute to the valley glaciers below. The final stage is the pyramidal peak. So you remember the picture at the start was the Matterhorn, which is a classic pyramidal peak, because the corries become armchair shaped and they get separated by really sharp knife edge ridges called arêtes. Notice a French word there. We said there are words from different languages. And if three or more corries develop on the side of a mountain, on three sides of a mountain, or you could get four on four sides of a mountain, they create a pyramidal peak. And the debris is deposited later on as till plains, terminal or push or recessional moraines. And the finer material is then carried much further by meltwater in suspension. So as we said before, do have a look over that later. There's an awful lot of information packed in there. And we're now going to move on to an activity with Alice called Beat the Teacher.
Thank you, Brendan. That was really informative and a really good focus on named processes, which is always something that we're going to need to get into our explanations. Okay, so an opportunity here to beat the teacher here, thinking about what the differences are between warm and cold-based glaciers. You're going to need to spot the deliberate mistakes on the next slide, and then you could put into the chat what you think perhaps might replace some of those words. So let's have a look at what the teacher's written to start with. Okay, so we've got a paragraph here introducing what are called warm-based glaciers, and a second paragraph here talking about cold-based glaciers. I'm going to give you a little bit of time to read that through, and if you're watching on catch up, of course, pause the video, read it through and think about what doesn't look right. What do you think the teachers got right in this text? Okay, you've had a little bit of time to have a look at it. As I was scanning through that, some things jump out because there are some contradictions within the same sentence. So let's have a look at the errors in case people hadn't found them all, and start you thinking about what you would write instead of those errors. So in that first paragraph, we've got four or three errors, but in the second we've just got the two. What would you write instead? Some good ideas in the chat there about how we might change that first paragraph. Quite a few people have spotted the idea that perhaps warm-based glaciers are not found in polar latitudes. Just have a look and see if there's anything else. How would you replace, now that we can see the errors, what words are we going to need to replace those? Okay, so if we could reveal the correct terms, and I will read this through. So if you were thinking that glaciers are basically cold, you are underthinking it clearly, because in terms of the internal temperature of a glacier, it does vary with depth and is affected by both the depth of ice above it and the resulting pressure, but also it's affected by geothermal influences. So glaciologists and scientists actually can construct graphs showing the increase or decrease in temperature by depth within a glacier. If they construct that graph to show in cross section what that looks like, and they're quite different between warm and cold-based glaciers. So this big difference is linked to where they are found, which you'll see when you look at the explanation, and therefore what the climate is like. More particularly, what sort of temperature fluctuations occur across the year. So warm-based glaciers are found in, you got it, temperate latitudes with a maritime influence. Precipitation rates are high with plentiful winter snowfall, but warm summers leading to a significant seasonal melting. The subglacial meltwater provides lubrication, which permits basal sliding and surging of fast-moving or mobile glaciers. Consequently, the glaciers rapidly modify the landscape by erosion, transportation, and deposition. Other factors which enhance these processes include their high susceptibility to geothermal heat and base pressure melting points of -1 degrees or less. So cold-based glaciers are different. They're found in different places. They're found in higher latitudes in polar regions. Precipitation rates are low. We know that because Antarctica is a cold desert with small amounts of annual snowfall, but with very little, if any, melt. As a result, the ice can be very old and remains below the melting point, except for the surface layers. This means there's little meltwater and low susceptibility to geothermal heat, and they move relatively slowly rather than we had fast there, which isn't even grammatically correct, and are often frozen onto the rocks beneath and beside them. Internal flow, creep, and deformation are dominant. Consequently, the process of erosion, transportation, and deposition are relatively slow. So who knew, John? Warm-based and cold-based glaciers, completely different, linked to their location and the climate where they're found.
Thanks, Alice. And that's a really good revision technique there, to look at something that's all correct and then make errors in it, and then perhaps revisit it later and see if you can fix those errors. Okay, we're now going to look at a picture grid with 6 questions. And one of the key themes, key challenges for you at A-level is to try and put together all the things you've learned, to try and consider what goes on in landscapes in general. So the examiners are very keen that you try to think of the landscape in a sort of totality, in a synoptic way. So a good way to do that is to look at a really good picture of a landscape. And we're going to look at that now, but we're going to look at it one piece at a time, combined with some questions that are actually sort of related to the landscape as well. And the final question will be very much related to the totality of the picture. So let's reveal the first question. By the way, where it says what's the image behind the grid, you don't have to answer that till the end, okay? So don't worry about that. Let's just look at each of these other questions first. At the start of a glacial advance, what name is given to the upland area where the ice budget is positive? So ice budgets are something you need to know about. What do you think that is called? The area where the ice budget is positive. Jot down your ideas in the chat or on a piece of paper and have a think about that for a moment. This is to do with ice budgets. So the correct answer to that is it's called the zone of accumulation, and that's where there's more glacier ice being supplied to that particular area than there is leaving the area by melting or other processes. Okay, the second question. What name is given to the area of an alpine glacier with a negative glacial budget? Here's glacial budgets again. And it would usually be during the summer months. So what name is given to the area of an alpine glacier with a negative glacial budget, often during the summer? Jot down your thoughts there. I think someone's got that. Again, a couple of people have got that because they had actually considered it's sort of the opposite of the first question, which is a zone of ablation. So you would quite often see that at the snout of a glacier. Third question. You can see the landscape beginning to appear, by the way. When a glacial advance occurs in a river valley, the ends of former interlocking spurs are removed by glacial erosion. What adjective is used for the spurs following glacial retreat? Okay, so right, it's definitely not Tottenham. That's a joke answer, isn't it? Yeah. I see where I see your thinking there though. So, yes. So, right, the correct answer is, of course, truncated spurs. Let's see some behind that question. You can see the spurs there have been truncated. You can almost see how they used to move into the valley at a much more gentle slope, but the glaciers literally sort of cut the end off them. Next question. What name is used to describe the rocks deposited by a glacier during a pause in glacial retreat? What name is used to describe the rocks deposited by a glacier during a pause in a glacial retreat? So this is to do with the fact that glaciers, when they retreat, don't retreat suddenly or just kind of slowly. They tend to do it in stages, in fits and starts, and they will often stay in one place for quite a while. So what do we call that? Those rocks that are deposited, which mark that point where the glacier was for a while. Okay, some people have got the right answer, some half right. The correct answer is recessional moraine. So these are slightly different to terminal moraines, which you would get at the very end of the glacier. These represent stages in the retreat of the glacier, almost marking where it was for a while. And when I say for a while, it could be there for hundreds or even thousands of years and then move back a bit further. Okay, next question. What name is given to a small stream, which you will see in a moment when we take the question away? What name is given to a small stream left behind in a glaciated valley after the glacier has melted away? Some people have often told me this is their favorite glaciation key term. Okay, the answer is a misfit river or a misfit stream. And if we take the question away, we can see one. You can see how this little misfit stream, no way would that have been able to erode that valley. So it's all that's left after the glaciation, and it's still draining that valley, but it couldn't possibly have created the erosion you can see in front of you. Next question. What term is used to describe frost-shattered rocks that fall from high crags and collect on the lower valley sides and floor? And once again, you'll see some of these when the question disappears. So what term is used to describe frost-shattered rocks that fall from high crags? They can be quite dangerous. They can fall in and hit people, and sometimes occasionally sadly kill people. It doesn't really happen too much in this country, but does happen in the Himalaya and other high regions. So those are called Good guess. Go for it. The correct answer is scree. So let's reveal the complete picture. What's the image behind the grid? What would you call that landform you can see in front of you in totality? Before we reveal the answer, this was taken during an A-level field trip where I took some sixth formers to Snowdonia. So if any of you have been lucky enough to go up to that part of the world, and doubly get this kind of weather, you're very, very lucky. So this is a U-shaped valley, but we could also perhaps more accurately say it's a glacial trough. And this is the Franken Valley in Snowdonia, very famous glacial trough. Right, moving on now to, let's see.
Aha! Thank you, Brendan. And that alert is alerting us to the fact that we have a case study here. Yeah, so just the point in the revision session, we're reminding you about the fact you do need to know about some named specific places, and examiners may ask you to discuss something with regard to a glacial environment you have studied. Now, one of the case studies you need is a glacial environment at a local scale, and here at Tutor2U, we look at Snowdonia. So we remember its location, of course, it's in North Wales, and that it's a glacial landscape affected most recently by the ice advance of the Divensian period, which is about 110,000 years before current era to 12,000 years before current era, though this period of ice advance reworked a landscape that had already been shaped by earlier glacial periods that occurred periodically across the Quaternary era. It's an area, as we can see from that photograph, which includes a whole range of glacial landscapes, and landforms from arêtes and corries, or as we know they're called coombs in Wales, to ribbon lakes and glacial troughs. And for your own case study, you need to know something about both its formation, and you need to be able to identify some key features that demonstrate the evidence of its glacial past. Now, clearly today, Snowdonia is a place of recreation as well as agriculture and some industry. But rather than going into its human geography, and I believe, John, we have a picture of someone standing atop a mountain there, I would suggest that thinking about human geography and the way people interact with cold environments, you'd be better served focusing on that, the challenges and opportunities they present, with regard to perhaps your contrasting case study, which is the second case study we need for glacial landscapes and systems, and something we'll be touching on in our second session next week. So I would say, in addition to thinking about formation and the landforms that are characteristic of your UK case study, I hope you've had a chance to engage with some quantitative data based on fieldwork, whether you've been or whether you haven't. And that's really good practice for the sort of questions we see in exams with unseen fieldwork data, which might be presented to you that you need to make sense of, analyse, even use a statistical test on, because remember, the statistical skills are back for 2023. So just remember all of that. Brendan, I believe you're going to finish our session with some quick fire multi-choice quiz questions for those people still with us.
I am indeed. Thanks, Alice. Really good to refresh our minds there on the wonderful landscape of Snowdonia. Okay, here are some questions to finish off. These are straightforward multiple choice questions. And the first two feature a climate graph. And I'm sure you've learned climate graphs in the past and been reminded of them recently. So the climate graphs, the convention will be that the line graph refers to the temperature and the bar part of it, the bar chart, refers to the precipitation, whatever type of precipitation that might be. So for question one, you have to select the three correct characteristics linked to the climate graph in the correct order. So the first one must be the polar region, the second one the correct biome, and the second one the correct type of precipitation. So is it answer A, Arctic, polar, high snowfall? Is it B, Antarctic, tundra, low snowfall? Is it C, Arctic, tundra, low snowfall? Or D, Antarctic, polar, low snowfall? So if you just jot down 1 and a letter in the chat, and we have correct answers coming in. Well done. So the answer is C. It's an Arctic polar region, and it's a tundra biome with low snowfall. The reason that we know it's Arctic, of course, and not Antarctic is because if you look at the peak temperatures, they're occurring in the months when we in the Northern Hemisphere would have our summer. So it can't possibly be in the Antarctic. Okay, let's move on to the question 2. This is a different graph. Same sort of question though. Select the 3 correct characteristics linked to the climate graph in the correct order. So first of all, the polar region, then the biome, then the precipitation. So this climate graph, take a moment to look at it. So is this showing A, Antarctic, tundra and low snowfall? Is it showing B, Antarctic, polar, negligible snowfall? It's showing C, Arctic, polar with negligible snowfall? Or D, Arctic, tundra and low snowfall? And good, at least 2 correct answers. Well done. They will be, yes, so Antarctic, polar region, polar and negligible snowfall. You can see it's Antarctic because unlike the first chart, this one has the peak temperatures in what would be the Northern Hemisphere winter, but that would be the Southern Hemisphere summer months, sort of round, November through to January. And you can see as well that there is negligible snowfall. In other words, you can hardly measure it, which is often a bit of a surprising thing for Antarctica. It doesn't snow very much, but it never melts. Okay, question 3. Select the correct statement about the distribution of cold environments. Take a moment to look at the chart there, and there's a key as well. So you have to just simply choose the correct statement about the distribution of cold environments. So make sure you know this. This is fairly straightforward multiple choice, but make sure you know other things about this as well. So would it be true to say that A, they can occur at any latitude, B, they're only found in polar regions, C, they're not found in Africa, D, only found in high latitudes? And the correct answer is, of course, that they can occur any latitude. There are cold environments right through all of the latitudes, including the equator in the very high mountains of East Africa, where there is actually a glacier or 2 at the top of the highest points there, like Kilimanjaro. Okay, question 4. Select the correct order of label numbers showing these items. So we have, in the correct order, you can see a photo there which I took on a recent holiday to Ireland. So you've got 5 items. You have to rearrange the numbers in the correct order of the words. So you have arete, Corrie Lake or Tarn, Corrie Lip, Hang Valley, Plucked Back Wall. So I hope that makes sense. If you just choose the numbers that you think follow the order of the words at the top. So if you make your selection, I'm not going to read them all out. Have we got a correct sequence? Anybody? Right, I think we do. And the correct sequence is 5, 3, 2, 1, and 4. So well done if you got that. Next image is another image I took in Ireland earlier this year, and this is a large boulder. So in a cold environment, what process of weathering is likely to have caused this large boulder to break in 2? It almost looks like you could put it back together again, like 2 bits of a jigsaw. So is it A,
aeolian processes, B, chemical reactions, C, animal activity, or D, frost action or freeze thaw? Lots of good answers there. Yep, well done. This is a classic example of frost action. You can see water must have got into the rock, into a crack in the rock, and just kind of prized it apart as it expanded and then thawed, and the rock just fell apart. Question 6. Here's another one from a trip to Yorkshire. How can boulders such as the Norba erratics in Yorkshire, this is a famous field of erratics, erratic boulders, how can they offer the greatest assistance for the study of glaciation? So do they show A, evidence of ice direction, B, shelter for scientists, C, evidence of ice duration, or D, evidence of climate change? And yep, got some good answers there. Yep, well done if you got that. So that is correct answer is evidence of ice direction, because these boulders, often the rock you can see there standing up is not actually the same as the rock underneath it. So it must have been brought from somewhere else. So if you can trace back to where that kind of rock comes from, you can then work out the direction of ice flow. So these are really important for scientists to study. Okay, next question. Here we have a beautiful landscape in the west of Ireland, and you have to consider what this is all about here. You have to select the correct name for the depositional landscape, characterised here by what are called drumlin swarms, and they're formed from what's called lodgement till. So what would drumlin swarms be known as? Would it be A, Easter eggs landscape, B, casket of eggs landscape, C, basket of eggs landscape, or D, bucket of eggs landscape? A few similar answers there, easy to make a mistake. What have we got? Yes, okay. The correct answer is basket of eggs landscape. That's what that's known as. Okay, number 8. This is not one of my holiday snaps, I'm afraid to say. I would have loved to have taken this picture, but I didn't. When two glaciers merge, their lateral moraines, marked by the number 1 on the photo, can join to become medial moraine, which is marked by number 2. What name is then given to the moraine at a glacier snout? So both of these moraines might eventually contribute to another type of moraine. Would it be A, fixed moraine, B, end moraine, C, nose moraine, or D, terminal moraine? Let's see. Yep, I think we've got a few good answers there. The correct answer is terminal moraine. It is at the end, but that's not the term we use. So B is not correct. It is therefore D. Right, number 9. Question number 9. What French term, again, we've talked about this before, we have other languages coming into glacial terms. What French term is used for resistant rocks that are polished with striations on their stoss slope and jagged on their lee side due to plucking? So we have 4 choices here. Is it roche cheminée, roche dragée, roche moutonné, or roche purée? And the correct answer is roche moutonné. Well done if you got that. And that literally means rock sheep. That's what that word is from. Okay, next question, which I think is the final one. Approximately how long ago, and look at the diagram to help with the map, I should say. Approximately how long ago was the last glacial maximum? Notice it's spelt with capital letters because it's a key term. It's a thing. The last glacial maximum, when was it? When global sea level was over 120 meters lower than it is now. Was it A, 20,000 years ago, B, 200,000 years ago, C, 2 million years ago, or D, 2 billion years ago? I got some good answers, maybe 1 or 2 not quite there, and the correct answer is 20,000 years ago. So in terms of how old the Earth is, very, very recently. Okay, that's that. And we're now just going to reflect on some additional support which you can gain through Tutor2U, such as the Glaciers revision notes for A-level and IB geography. There's also a teacher pack for any teachers that are watching, or if you're a student, you want to tell your teacher about this. Tutor2U's Glacial Systems and Landscapes Core Resource Pack. So thank you very much for following our study tonight on glacial systems, and it's been a pleasure to discuss this wonderful topic with you guys.
Thanks very much, Brendan, and thanks, of course, to Alice as well. Thanks to anybody who's been taking part with giving some answers to some of the questions. I hope you've enjoyed it. This evening's live stream. We've got another one next week, Brendan, haven't we? Another second Glacial Systems and Landscapes live stream. I'm correct there?
Yes, we have, and that's going to concentrate on periglacial landscapes and fluvioglacial landscapes.
Wonderful, wonderful. A quick reminder to everybody that the PowerPoint that we've been using tonight will be available to download from the Tutor2U website as soon as we've finished this live stream. And once again, thank you to everybody, and we'll see you next week. Goodbye, everybody.
Bye.
Thanks very much. Bye.